Hi guys, if you have questions, email me or write a comment.
Today I will talk about horizontal asymptotes of radical functions. But before we do that, we need to remember that square root of x squared will be equal to absolute value of x, since square roots can never be negative. And since we're gonna have absolute value of x, then we have to remember definition of absolute value, which is negative x when x is less than 0, and x as it is when x is a positive value greater than 0. And of course it's equal to 0 when x is 0. And keep in mind that limit any number over x as x approaching infinity or negative infinity will be equal to 0. We said that before. So after we remember all of these and keep them in our mind, we need to be able or to try to find horizontal asymptotes of a function like x over square root of x squared plus 2. Now, how am I gonna do this? Before we said we're gonna use the coefficients of x with highest power, but in this case, the highest power is under square root. So how am I gonna deal with this? I will tell you the shortcut, but let's explain why would that shortcut be. We'll follow the definition. How do we find horizontal asymptotes? It's limit of the function when x approaching either positive or negative infinity. We'll take them in parts. Let's say limit as x approaches infinity, and if you still remember, and if you don't, you can go back to my explanation in the other video. X over square root of x squared plus 2. The way to evaluate limit as x approaching infinity was by dividing with x with highest power. So I had to divide inside the square root with x with highest power. So here, square root of x squared. And of course, limit as x approach infinity, the first case. So this will be equal to what? Let's take it down for a space. So this will be equal to limit x over, this is square root of x squared, and as I said, square root of x squared is equal to absolute value of x, not x only. So this is absolute value of x over, here inside the square root we will have 1 plus 2 over x squared as x approaching positive infinity. Now we have absolute value of x here, and x is approaching infinity, which means x is a positive value. So according to this case, I'm gonna use, instead of absolute value of x, I'm gonna use x itself. So in this case, we'll be having limit x over x over square root of 1 plus 2 over x squared as x approach infinity, which means limit 1 over 1 plus 2 over x squared under square root as x approach infinity. Now if you try to evaluate the limit, you will get 1 over square root of 1 plus 0, which is 1. So we have y equals 1 as a horizontal asymptote. Okay, what about limit when x approach negative infinity? What's the difference? Actually, we're gonna follow the same steps. We will reach this step, so it will be x over absolute value of x over square root of 1 plus 2 over x squared. Now the absolute value of x in this case, the absolute value of x will be equal to negative x since we're approaching negative infinity, and negative infinity is less than 0. So absolute value of x will be equal to negative x. So in this case, we'll be having limit as x approach to negative infinity of x over negative x over square root of 1 plus 2 over x squared, which is limit negative 1 over square root of 1 plus 2 over x squared as x approach negative infinity. Now if you try to substitute or evaluate the limit, you will get negative 1 over square root of 1 plus 0, so it's negative 1, which means we'll have another horizontal asymptote as y equals 1 and y equals negative 1. That's why radical functions or square root functions are special about asymptotes, because they will have two horizontal asymptotes, like this example, y equals 1, y equals negative 1. Now, does that contradict what we said before about the coefficients of x with highest power? Actually, no. Because if you look at the function, we said coefficients of x with highest power, the coefficient here is 1, the coefficient here is 1, but we need to take care that I'm talking about square root of x squared. And because of the absolute value, I'm going to use square root of 1 and square root and negative square root of 1. So we'll get 1 over 1 and 1 over negative 1, negative 1 over 1. That's why we'll have two horizontal asymptotes here.
Remember to like, share, and subscribe, and write your questions via email or comments.